Hello students, welcome you to this video. So in this class, I'm going to teach MCQs from the second chapter, okay? So hope you are thorough with all the results, then it will be easy for you. But while I'm teaching every sum, I'll discuss the related results also, okay? Look at the first question. NC3 equal to NC2, then the value of NC4. So we want to find NC4 we want to find. For that first we need n value, right? So n you can find from here. But there is a formula, there is a result NCA equal to NCB, which implies either A equal to B or need not be every time, or A plus B equal to N. So if you apply that result here, either A equal to B means either 3 equal to 2. 3 equal to 2 is not possible, right? 3 equal to 2 is not possible. So you cannot use this result here. So you must use this result A plus B equal to N. So here N is N only. So N is equal to A plus B, that is 3 plus 2. So you are getting N equal to 5. Don't simply mark 5 there. That is N value. But what they asked here, they asked to find NC4. So therefore NC4 is equal to, instead of N you write 5, so it is 5C4. 5C4 is same as 5C1, but 5C1 is what? 5 only here. Okay, so in this case your answer is 5. N value also 5, but not because of that the answer is 5. NC4 they asked. So unfortunately in this question that value is also what? 5 only. Okay, so read the question very carefully and do. Now let's move on to the second question. The value of n when np2 equal to 20, np2 equal to 20, you know how to expand. There is a formula npr, n factorial by n minus r factorial. But easy method, np2, start from n, reduce 1 by 1, write 2 terms, right? No denominator. In combination, you write the denominator also 2 factorial. But here np2 is n into n minus 1 equal to 20. You can multiply, you'll get a quadratic, solve it. That is one method. The easy method is n into n minus 1 is because it's an objective question, just we need the answer, right? 20 you can write it as 5 into 4, 5 4s are 20, 5 into 4, that 4 can be written as 5 minus 1. Now if you compare both similar, same type, right? N into n minus 1, 5 into 5 minus 1, instead of n we have 5, so the second option is the answer. Third question. Number of ways of selecting, that you do very careful. Selection or arrangement. Selecting you have to use combination, for arrangement you have to use permutation, right? The number of ways of selecting, 4 players out of 5. Total 5, you are selecting 4. So 5C4 is same as 5C1 because there is a formula NCR is equal to NC n minus R. When the second number is more than half, you can do this one. You can use this one. 5C4 is same as 5C. 5 minus 4, 1. 5C1 is 5. So here the answer is the fourth option. Now let's move on to the next question. Question number 4. NPR is equal to 720 into NCR. There is a relation between NCR and NPR. NCR is same as NPR by R factorial. So instead of this NCR, I am using this result. Now in both the sides you cancel this NPR. Cross multiply, R factorial is equal to 720. 720 means left side is factorial, so convert the right side also into factorial. For that, factorial means what? 1 into 2 into 3 into 4 into, keep on writing till you get the product as what? 720. So multiply 1 into 2 into 3. Now it is 6 only. We have to get 720, right? So into the next number 4. So now 2 3s are 6 4s are 24 into 5. 24 into 5 120. Into 6, 120 into 6, 720. So stop here. So that is R factorial is equal to 6 factorial because 1 into 2 into 3 into up to 6. Both are of the same type, both are factorials. Compare them, R factorial is 6 factorial, so R is equal to 6. What they asked to find? Then the value of R, it is 6, so option number C, right? So that is sum number 4. Now let's move on to sum number 5. The possible outcome when a coin is tossed 5 times, coin, it should come in your mind 2 raised to n. If it is a die, 6 raised to n. Already you have studied in the lower classes, right? tossed 5 times, so it is 2 raised to 5. They didn't ask you to write how many, only they asked. 2 raised to 5 is what, 32? But here option 2 raised to 5 itself given, right? So your answer is A. Now listen the sixth one, the number of diagonals of a polygon of n sides. So totally there are n sides, no 3 points are collinear. Number of diagonals they asked. So listen, already you have studied. Suppose there are n points. N vertices are there, no 3 points are collinear. Then how many lines can be formed? Number of lines can be formed is NC2. Because for a line you have to connect 2 points at a time. Number of triangles, NC3, because you have to connect 3 points, right? Now number of diagonals also line only, right? So NC2, but every line is not a diagonal. Sides are not diagonal. So sides should be removed. So here n points, so there are n sides. That n you have to remove. Okay, so the remaining are diagonal. So NC2 minus n. So here the correct answer is what? B, because the question is number of diagonals. Now let's move on to question number 7. The greatest positive integer which divides n into n plus 1 into n plus 2 into n plus 3. The greatest number, 4 consecutive natural numbers you take. For example, you can do very easily. You take, say, natural number 1 into 1 plus 1, 2 into 3 into 4, right? So this is divisible by what? 4 3s are 12, 12 2s are 24. Any number you take, 4 continuous numbers you multiply, definitely it will be divisible by what? 24. Sum number 8. N is a positive integer. N is a positive integer. That's a natural number. Then the number of terms in the expansion of x plus a raised to n. X plus a raised to n. The power n is a positive integer or natural number. Suppose the power is 17. 17 plus 1. 18 terms will be there. Here the n is there. So how many terms will be there? Means what? N plus 1 terms will be there. So second option. Now question number 9 you see. For all n greater than 0, nc1 plus nc2 plus nc3 plus etc. ncn. These are all binomial coefficients, but actually binomial coefficients starting with 0, right? nc0 plus nc1 plus nc2 plus etc. plus ncn. So these are sum of the binomial coefficients is equal to 2 raised to n. But here one term is missing. Which term is missing? They are starting from NC1 only. Okay, only from here they are asking. So this one is missing. What is NC0? It is 1. 1 plus this part is equal to 2 raised to n. So we want this one, right? So this is equal to, take this 1 to that side, 2 raised to n minus 1. So be very careful in this one. Okay, if they start with NC0, then your answer is 2 raised to n. Now let's move on to question number 10. So all these sums very simple sum, but there are certain sums you have to work it out. Okay. Look at this question. The term containing x raised to 3 in the expansion of this. So x plus 2y raised to 7, power is a positive integer. Power is 7, so 8 terms will be there. The term containing x cube, right? The term independent of x, right? Everything you have studied. Compare with the standard form, x plus a raised to n. X is x only, a is 2y, n is 7. Tr plus 1 is, this is the main formula, ncr, x raised to n minus r, a raised to r. N is 7, 7cr, x is x only, raised to 7 minus r, a is 2y raised to r. So x terms you combine, here there is only one x term, so equate that x power with 3, because we want x cube, right? So this you take it as equation number 1. Now equate that power, put 7 minus r is equal to 3. So r is equal to 7 minus 3, it is 4, substitute the first equation. So T5 is equal to, for r you put 4, 7c4, x raised to 7 minus 4, 3, into 2y raised to r value 4. What they asked the question? The term containing x cube. Yes, x cube is there. Which term? Fifth term. R is 4. So 4 is not the answer. Fifth term containing what? X cube, right? So fifth term containing, so your answer, they didn't ask you the coefficient, nothing, they didn't ask. Which term containing? Okay, so R you are getting R value 4, but you substitute in one R plus 1, so T 5. So fifth term containing X cube term. Okay, now let's move on to question number 11. The middle term in the expansion of, they asked to find the middle term. Okay, so another 3-mark question actually, right? So compare with the standard form, x plus a raised to n, x is x only, a is 1 by x, n is 10, it is even number. For middle term alone, you have to look into whether it is odd or even, right? Suppose the power is even, for example, the power is 4, 5 terms will be there. 5 terms means there is only one middle term. So when n is even, one middle term. When n is odd, 2 middle terms. So here n is even, so there is only one middle term. So before that you write general term T r plus 1 is equal to NCR x raised to n minus r a raised to r. Substitute the known values, n value 10, 10CR, x is x only raised to 10 minus r, a value 1 by x raised to r. So this is TR plus 1. Now we see which term you need. We want the middle term, right? I'm writing all the steps so that it will be easy for you to do the 2-mark, 3-mark questions. Middle term. N is even, so n by 2 plus 1th term. N is 10, so 10 by 2, 5, 5 plus 1, 6. So 6th term you are supposed to find. How can you find the 6th term? Put r equal to 5. Put r equal to 5. So T6 equal to, because 5 plus 1, 6, right? But wherever r comes, you put 5. So 10C5, x raised to 10 minus 5, it is 5, by 1 by x raised to 5. 10C5 is, okay, we write 10C5, the answer, they didn't change that, okay, into x raised to 5. 1 raised to 5 is 1 by x raised to 5, that x raised to 5 cancel, so you are getting 10C5, so the correct answer is what? Second option, 10C5. Question number 12. The constant term, that is the term independent of x. Earlier we did x cube, equate the power with 3. But now the term independent of x or constant term, equate the power with 0. So compare with the standard form, x plus a raised to n. X is x only, a 2 by x, n is 6. So TR plus 1 is, what's the formula? NCR, x raised to n minus r, a raised to r. So that is n. What is n here? 6. So 6CR, right? X is x only, x raised to 6 minus r, a raised to r. What is a value? A value 2 by x raised to r, right? So now x values you have to combine. So 6CR, x raised to 6 minus r, 2 raised to r by x raised to r, right? By x raised to r. Now you can combine that x terms, you combine 6CR, 2 raised to r, x raised to 6 minus 2r. This is r, right? So minus r, it is 2r. So since we want the constant term, equate the power with 0, right? So put the power 6 minus 2r is equal to 0. So you are getting 6 equal to 2r, or r equal to 6 by 2, r equal to 3. Substitute this value in the first equation. So this is TR plus 1. So if you substitute the first equation, T4, for r you put 3, right? So 6C3, 2 raised to 3, x raised to 6 minus 2 into 3, 6. So definitely you won't get that x term. 6 minus 6 is what? 0. Any number raised to 0 is 1. So you are getting 6C3 into 2 cube into 1. So this is the answer, but how they given the answer? They simplified, right? So you expand it. Very simple calculation, right? 6C3. So 6C3 means 6 into 5 into 4 by 1 into 2 into 3. 2 cube is 8. 2 into 3 is 6, you cancel. So when you simplify this, 5 fours are 20 into 8, right? 160. So your answer is the third option is the correct answer. Okay, now let's move on to question number 13. The last term in the expansion, very simple thing, right? Suppose x plus a raised to n. The first term is x raised to n. The last term is a raised to n, right? The coefficient will be 1 only. So here they asked to find the last term equal to root 2 raised to 8. So how can you simplify? Root 2 into 8 times r, very simple. If you want to do root 2 means 2 raised to half. Suppose very high power, then how will you do that, right? Raised to 8. So a raised to m, the whole raised to n is a raised to mn. You have to multiply these two. So 2 raised to 1 by 2 into 8. So multiply, it is 4. So 2 raised to 4, 2 into 4 times, right? It is 16. So your answer is 16. That's the second option. Okay, now let's move on to question number 14. Listen. Kx by x plus 4 into 2x minus 1 equal to, we want to find k value, right? So partial fraction, so if you simplify, you have to get this, right? Right side you take LCM, what's LCM? X plus 4 into 2x minus 1. You will get 4 into 2x minus 1 plus 1 into x plus 4. In both the cases, cancel the denominator. So kx equal to, expand the numerator, 4 2s are 8x minus 4 plus 1 into x, so x plus 4. These two cancel. You are getting kx equal to 8x plus 1x is what? 9x. So comparing that, equate the coefficients, you are getting k equal to 9. So first option is the correct one. Okay, now let's move on to question number 15. The number of 3-letter words, can be formed from the letters of the word. It is number. Okay, so this is what given. So how many letters can be formed? Okay, please listen here. The number of 3-letter words can be formed from the letters of the word number with the repetition is allowed. See which letters you have? N, U, M, B, E, R. See how many letters here? 1, 2, 3, 4, 5, 6. You have 6 letters with you. No letter repeats, right? So you have 6 letters. We want to form a 3-letter word, whether it is meaningful or not, doesn't matter, okay? How many ways you can fill it? Repetition allowed. So you have 6 letters. So first place can be filled in how many ways? 6 ways you can fill, right? Now how many you have? You have 5 if repetition not allowed. Now repetition allowed. So still you have 6. So second place you can fill in 6 ways. Third place also you can fill in how many ways? 6 ways. So the answer is 6 into 6 into 6. So the answer is 216. Suppose if they say repetition not allowed, first place you can fill in 6. So one letter we used, remaining we have only 5. So go to the next place with the option of 5. Now we have only 5, right? Second place can be filled in 5 ways. So 2 letters we used, right? Remaining you have 4. With that 4, you go to the third place, so that can be filled in 4 ways only. Okay, that is if repetition is not allowed. Here repetition allowed, so 6 into 6 into 6. Okay, so it is 216. Now sum number 16. Listen carefully this one. The number of parallelograms can be formed from a set of 4 parallel lines. 4 parallel lines. 1, 2, 3, 4. 4 parallel lines. L, M, N, O. Okay, there are 4 parallel. All the 4 lines are parallel, right? The number of parallelograms they asked. Number of parallelograms that can be formed from the set of 4 parallel lines intersecting another set of 3 parallel lines. Another set of 3 parallel lines. 1, 2, 3. Another set of, so I'm taking them as P, Q, R. So we have to get the parallelogram. So you know what is parallelogram? This is a parallelogram, right? So this is a parallelogram, right? So 2 lines, I want to take 2 parallel lines in this direction. I want another 2 parallel lines in this direction, okay? So 2 parallel lines I want. So in this direction, totally we want, in this direction I want 2 parallel lines. How many lines are there in that direction? 4. So from that 4 I want 2. So 4, what do you write? 4C2. Then in this direction I want 2. In that direction how many are there? 3 are there, right? So from that 3 you select any 2. So 3C2. So total number of parallelograms can be formed is 4C2 into 3C2. Okay, 4C2 into 3C2. So you know how to do the calculation, right? 4C2. What is that? 4 into 3 by 1 into 2. 3C2. 3C2 is same as 3C1. 3 minus 2, 1. 3C1, it is 3, right? So 2 table you cancel 2. 3 3s are 9, 9 2s are 18. So the correct answer is what? The first option. So listen very carefully. So here they said there are 4 parallel lines, right? 4 parallel lines in this direction, 4 parallel lines in this direction, 1, 2, 3, 4. 3 parallel lines in the other direction, 3 parallel lines in this direction. To get a parallelogram, see, so you can count it. It's a small number, so even you can count, take 1 at a time, then 2 at a time, 3 at a time like this, then 4 at a time like this, like this. So many things are there, right? But that's not the correct way. To form a parallelogram, you need 2 lines in this direction, right? So in that direction, 1, 2, I want 2 lines. But in that direction, how many lines are there? 1, 2, 3, 4. From that 4, you take any 2. So that can be done in 4C2 ways. And I want another 2 lines in this direction, right? Another 2 lines in this direction. But how many lines you have? 1, 2, 3 lines in that direction. From that 3, you take 2. So 3C2. So total number of parallelograms, you have to multiply these two. Okay, this is how you have to do. Now let's move on to sum number 17. There are 10 true or false questions. There are 10 true or false questions. See, suppose to take the first question, true or false. Only 2 options there, no? So that question can be answered in how many ways? 2 ways you can answer, right? So this question can be answered in how many ways? How many options are there? 4 options. So this answer can be answered in how many ways? 4 ways you can answer, right? So this question can be answered in 4 ways. The previous question you would have answered in 4 ways, but correct answer is only 1, right? In this exercise, totally there are 25 questions. So all the 25 questions, each question can be done in how many ways? 4 ways, 4 ways, 4 ways, up to 25, right? 25 terms. So your answer is 4 raised to 25 for this question I'm telling, okay? But here, there are 10 questions with only 2 options, true or false. So first question can be filled in how many ways? 2 ways. Second question can be written in 2 ways. Either you write true or false into 2. How many, like there, how many questions? 10 factors, right? So 10 questions for each question, 2 into 2 into. So your answer is what? 2 raised to 10. 2 raised to 10 is 1024. Okay, remember like this. Sum number 18, listen carefully. See what is given here. 5C0 plus 5C4. Then 5C1, 5C2, like there are a lot of terms there, listen. But there are some repetition, no? So see which terms are repeating. 5C1, this is also 5C1. 5C4, 5C4 can be written as 5C, 5 minus 4, 1, right? So these two 5C1, 5C2, 5C3, 5C4. Then these two left out. 5C0 and 5C5. This is 5C5. This also can be written as 5C5. Oh, you know 5C5 is 1, 5C0 is also 1. So 5C5 also how many times? 2 times. So you can write 2 times 5C4, right? So this is 5C1, this is also 5C1. 2 times 5C1. 5C2, 2 times. 5C3, 2 times. 5C4. 5C5, right? 5C5. That only I'm writing short. So if you want, you can write fully 5C1, 5C2, 5C3, 5C4, 5C5. I made small changes. 5C0 is same as what? 5C5. So this 5C5 and last 5C5. So 2 times 5C5. And this 5C4 is same as 5C1. So 5C1 plus 5C1, 2 times 5C1. You know, sum of the binomial coefficients is 1, right? So here, since 5 is there, you know, 5C0 plus 5C1 plus 5C2 plus 5C3 plus 5C4 plus 5C5, it is 2 raised to n, 2 raised to 5. Here one term is missing, right? 5C1 onwards we have, only this term is missing. What is missing? 5C0. What is 5C0? It is 1. Take this 1 to that side. So this part is equal to 2 raised to 5 minus 1. Okay, so this part can be replaced by, so this can be replaced by 2 raised to 5 minus 1. It's explanation given here. Okay, so now we just expand it. 2 into 2 raised to 5. 2 into 2 raised to 5 means 2 raised to 6 minus 2 into 1 is 2. 2 raised to 6 means 64. 64 minus 1, 62. But how they given the answer? They given the answer as what? Just 2 raised to 6 minus 2. Right? 2 raised to 6 minus 2. This is the answer. So option number first one, right? Option number A. Now let's move on to question number 19. See the 19th question. A total number of 6-digit number. 1, 2, 3, 4, 5. Sorry, 9-digit number, right? A total number of 9-digit number. 1, 2, 3, 4, 5. 6, 7, 8, 9, 9-digit number, which have all different digits. What are the digits you have? Decimal system, 10 digits. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, totally there are 10 numbers. So with this you have to form a 9-digit number, 9-digit number. Here since 0 is there, you have to be very careful. So total number of 9-digit number which have all different digits. So repetition not allowed. Repetition not allowed, because it is clearly given all digits are different. Okay, so please listen here. So the first one can be filled in. So totally there are 10 numbers. So this can be filled in what? 9 ways only, because 0 cannot be used here. So now among the 10, from this 9, one number we used. For example, we used one number. So remaining here 8 plus 1, 9. 0 can be used anywhere, right? So 8 plus 1, 9 numbers. So this can be filled in 9 ways. So from this 9, you used one number. Remaining we have 8. Then 7, right? Then 6, 5, 4, 3, 2. So now how to simplify? They didn't simplify. No? They put in terms of factorial. Into 1, there is no change, right? Even if you put into 1, nothing wrong in that. So up to 9, it is 9 factorial. Into what you have? 9. So the answer is 9 into 9 factorial. So that is the correct answer. 9 into 9. Suppose in the same question, if they say repetition allowed. Repetition allowed. So first place can be filled in 9 ways only. Then totally you have 10 digits, right? Totally 10 digits. So this place can be filled in any of the 10 numbers. So 10, 10, 10. Each place you can put what? 10. Because totally 10 digits. You can use any number anywhere except in the first place there. Otherwise it become a 8-digit number, right? So you have to be very careful. But in this case they said the repetition is what? Not allowed. So this is how we have to do this one. Okay, now let's move on to the next question. Question number 20. Look at this question. The number of ways to arrange the letters of the word cheese. C-H-E-E-S-E. Very simple question. How many letters are there? 1, 2, 3, 4, 5, 6. 6 letters can be arranged in 6 factorial ways. If there is no repetition, this is your answer. But there is a repetition. E repeats how many times? E repeats 1, 2, 3 times. So by 3 factorial. So your answer is 6. No other repetition, right? So 6 factorial can be written as 6 into 5 into 4 into 3 factorial. By 3 factorial you cancel, or you write 3 into 2 into 1, then you do that. Okay. So 6 5s are 30 into 4. It is what? 120, right? So option number A. Now question number 21. Listen carefully, very simple question. 13 guests has participated in a dinner. Number of handshake. So for handshake, how many person you have to connect? 2, right? So 13 guests. So for a handshake, take 2 person at a time. So it is 13C2. Okay, so that is your answer, 13C2. It is 13 into 12 by 1 into 2. So 2 table you cancel, it is 6. So you will get 78. Yes, that's your answer. Now question number 22 you see. Number of words with or without meaning that can be formed using the letters of the word equation. So how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 letters can be arranged in 8 factorial ways. But see the repetition. E repeats one time, Q, one U, one time. Every letter repeat one time only. So no denominator. Your answer is what? 8 factorial itself, right? So question number 23. Listen, sum of the binomial coefficients in a particular expansion is 256. Sum of the binomial coefficients is 2 raised to n, right? Then the number of terms in the expansion they asked you. Very, very careful in this one. Listen, 2 raised to n is 256. So since the left side is 2 raised to n, right side also write 2 raised to 256 means it is 2 raised to 8, right? 2 table 128. Again 2 table 64. Again 2 table 32. 2 table 16, 2 table 8, 2 table 4, 2 table 2. 1, 2, 3, 4, 5, 6, 7, 8. 2 raised to 8. So n is equal to 8. Immediately don't mark n equal to 8. It is wrong. N is 8, but they didn't ask n. In a binomial expansion, the number of terms, please listen, what is binomial expansion? X plus a raised to n. Here what is n value? 8. If the power is 8, how many terms will be there? 8 plus 1 terms. 9 terms will be there, right? So number of terms will be 9. So be very careful in this one, okay? So do it. Now let's move on to question number 24. It's a very simple question. Already we discussed this type. The number of permutations of n different things taken r at a time when the repetition is allowed. So n different things. So taking r at a time, right? So n different things are there. We need r at a time. So we want r at a time. So first one, there are n things there. So how many ways you can take that one? There are n things, no? You can take any one, right? Second one, totally there are n things. Repetition is allowed. So if not, you write n minus 1. Here repetition allowed. So that can be filled in n ways. N into n into n into like how many times? R times. Okay, so n into n means n square. N into n into n. 3 times means n cube. R times n raised to r. So the answer is the second option. Okay. Now the last question. You may think last question may be a little tough one. That's the easiest one. Sum of the binomial coefficients is 2 raised to n. Hope you understood all these things. We'll continue in the next video.